Hello everyone. Today we are going to see how we can do digital simulation in microcap. So you are already familiar with this window. Here in the left panel we have component library. We have already used analog primitives and analog library components. Let's see what we have in the digital primitive. So here if you see, you have the standard gates, flip-flop, programmable logic devices, A to D converter, digital stimulus, digital filters, and inside the digital library you have different ICs such as different gates, inverter which start from this 7400 and others, and also we have here ECL and programmable PLD, programmable logic devices. Okay, so let us start the simulation with a standard gate and let us use the inverter. So let me place here. Here we have different model for the inverter. These different models have the different low to high or high to low logic delay times. So here if you see, first one is program that propagation delay from high to low. And first one shows the minimum propagation delay, second one is maximum propagation delay, and this third one shows the typical propagation delay. The bottom one is from when our signal is going from low to high, what will be our minimum delay, maximum delay, and typical delay. So this first one has the 0. So let us use this, and now I am going to rotate it so that it will look similar to what we draw in our textbook or notebook. So let me connect to wire at the input and output, and now we have here our inverter. We can, by clicking on this node number icon, we can see what are the node numbers. So, and now we need a digital stimulus. So here if you go inside the component in the digital primitives, at the bottom there is stimulus generator. If you expand that, we have here digital clock, stimulus with 1 bit digital stimulus, 2 bit, 4 bit, 8 bit, 16, and others also. And we have here fixed digital also. So I am going to use a 1 bit digital stimulus, and let me connect it. So here if you see, we have to define at which time what will be our signal value. So here you have to write the name for this digital stimulus. So I am giving it name U1, and in the next line you have to define the time and the value. So at 0 nanosecond or 0 second, I am saying that my input is 0, and at 200 nanosecond my input is 1. At 300 nanosecond my input is again 0, and similar at 500 nanosecond I have 1, and that's sufficient. So okay, and now if you see, we have our input signal, we have our inverter. Let's start the transient simulation. So when you click on the transient, uh, here you will see that you already have the input output expression. So in the input we have time, and the output we have the digital signal for node 1 and digital signal for node 2, and our maximum runtime is 1 microsecond. So I'm going to run it. So here if you see, by after just clicking on the run, you instantly seeing the output which is inverted of our input signal. And to change this version and animate our this output, you can click on this animate button and choose this wait for time delay of whatever time you wish. So this value is in seconds, so I am going to wait for 1 second before changing our signal. So let me run it again, and now you see it wait for 1 second every time after changing our signal from 0 to 1 or 1 to 0. Okay, so this is our digital simulation. And the other way to make our circuit less complex, suppose you have a large number of component and you don't want to connect your uh, stimulus to the each component in that circuit. So you can name these wires. So let me delete this wire and move this input stimulus a little away. And now I am connecting a short wire at both input and output, and you can name these wires. So right now it gives a number for node, and now we will rename this node. So I am giving it a name A, and for this node, input node, this we want to connect with this stimulus, so we have to give it name A. And now if you see that your A and A is connected, so if I start my transient simulation again, now you have to change this. So now you have to make it digital output of A and digital output of T. And when you run it, so here you will see the same output. Okay, so that's one thing, and there are other things also. So suppose you want to use a 7 segment, so then you can go and search here in for 7 segment, like you can search for any component. Okay, just give me a minute. If you go in animation here also, you can find that animated 7 segment display. Okay, so you can place it here, and there are different input for this. If you double click on this, you will see, you can click on the syntax and read what it is. And also you can click on this filing. This will give you the idea of what this displays, and you can get the data sheet for that. And if you are using the 7 segment display, then you will also need to use decoder circuit, which can convert your digital or any other number into compatible format of the 7 segment display. So you can search here that BCD to 7 segment decoder. So here if you place, you have this 7448 IC, which is BCD to 7 segment decoder. So you will give your input here on A, B, C, D, and you can take the output from this O, A, B, C, D, E, F, G, H. So you can directly connect this like this, and you see your inputs are connected. And now you can give your different input on A, B, C, D, and you can generate whatever pattern you want from those digital stimulus, and you can see that your 7 segment is displaying that number whatever you are giving from your input. So that's it from my side on this digital simulations. Thanks.